Number 8, the rotational equilibrium recitation. We have this modern art exhibit, and it's being suspended here. And we are asked to figure out what the two tensions are and what the angle is, the missing angle here. So, first of all, there's going to be a weight force here. And yes, we have the tension T1, and we have the tension T2 here. So let's first look in the horizontal direction, the x direction. I know that T2 times the sine of theta 2 must be equal to T1 sine of 10 degrees. Now let's look in the y direction. I know that T2 cosine of theta 2 plus T1 cosine of 10 degrees must be equal to the weight. And the mass of the thing is 50 kilograms, so the weight is 500 newtons. So we can see we have three unknowns, T1, T2, and the angle. So let's look at this in terms of torque. The weight will not cause a torque about the center. Let's say the pivot point's here, about the center. The weight won't cause a torque, but the tensions would cause a torque. So we've got the torque from T2, which would cause it to be a clockwise torque, and from T1 would be a counterclockwise torque, and they must be equal. So the torque from T1 must be equal to the torque from T2. And the torque would be equal to the tension T1 times the lever arm distance, which would be 0.09 meters, times the sine of the angle. Now it's tangent to the circle, so that would be 90 degrees, so I can just leave that off. Sine 90 is 1. So this will be T2 times its lever arm distance, which would be the radius, which is 0.375 meters. So now I can figure out what T1 is in terms of T2. T1 is equal to 4.13 T2. So I could plug that in over actually either one of these two equations. I could plug it in. And let's plug it into the sine one. So I can plug this T1 over, T1 right here. And so what I'm going to get is T2 sine of theta 2 equals 4.13 T2 sine of 10 degrees. The T2's will cancel. And now I can figure out what theta 2 is. Theta 2 will end up being the inverse sine of 4.13 times sine of 10. And so I get an angle of 45.9 degrees. Once I know that 45.9 degrees, then I could go ahead and plug that in here. And I could go ahead and plug what T1 is into there as well. And now what I'll be able to do is figure out what T2 is. So this is going to be T2 cosine of 45.9 degrees plus 4.13 T2 cosine of 10 degrees equals 500. And so now I can solve for T2, and I get an answer for T2 to be 104.9 newtons. Once I know what T2 is, I can plug that back in up here to figure out what T1 is, which is 4.13 times as big, and I get T1 to be 433.6 newtons.